Hey guys, nice to meet you. I'm Luis Barbosa from Webira. I believe, let me share my screen. Right. So I believe we currently already use GitLab. So the idea of CI/CD you probably already aware of, especially the idea of having stages of a pipeline or CI/CD pipeline as containers. This very same idea applies to Kubeflow. The only difference here is that you're trying to create pipeline for machine learning processing, right? The whole process that you're going to use, and mainly I'm going to use GCP, in particular the AI platform here to perform a demo. In order to keep under 1 hour our session here, I try to initiate, do an early start here on our process. Let me access then the AI platform. We're going to use pipelines. And the first step here is to create a cluster. And within the cluster, we're going to deploy the pipeline Kubeflow infrastructure. So all right, so I'll create a new cluster. Gonna take a while. While is running, it's creating. Let's get started. So once again, nice to meet you. I'm Luis Barbosa. My previous experience, I work in the financial market, telecom industry, I'd say for the last 15 years. And more recently, I worked with digital marketing for a company based in Santa Monica. Then I moved to Google Brazil at the Google Ads department. And more recently, I joined Webera team to structure the new unit for artificial intelligence and machine learning. I'm also a PhD student for artificial intelligence here in Brazil, and also certified as a data engineer for Google Cloud Platform, and also a solution architect for AWS, right? You guys are already aware of Webira. I don't think it makes sense of going any further. Just to give an overview, what's cloud product infrastructure that are available under GCP. And of course, our main focus would be on Kubeflow today. But anyhow, to give an idea, GCP, for instance, in the same idea that you're talking here could apply also to AWS. GCP offer a pre-trained model, custom model that you can adapt and bring your own data. So you can use pre-trained models from Google with their own data and their own modules. You basically reuse as ready-to-use components and plugins. Then they have custom model in which you basically have pre-trained model and you bring basically our data. And once you have our data in, you can use the trained models. And lastly, that's the case that we're going to work here. We're going to create our own modules using our own data, basically using Google infrastructure. So within that 3 fronts, Google offer vision API, language API, time series analysis API, speech APIs, and so on, and what they call AutoML, which is the platform that offers pre-trained AI, in which basically we bring our own data, so we can train based on pre-trained model from Google, right? And lastly, the more complex case, more customized case, all the tools related to creating whole models from the scratch, use our own data, and Kubeflow apply exactly on that sense. When we're talking about AI, we have different stages, and we're going to see within Kubeflow, the idea of the pipeline is to model each one of those stages as a component, and then to structure a pipeline composed of these components, right? So have different stages and different business process for AI. Here, an example, have the process of ingesting data, preparing it, pre-processing, understanding, discovering, developing the model, creating the model, then training it, analyzing, testing, and finally deploying it in the production. So the idea of Kubeflow is to combine two interesting things, machine learning models and containers, especially containers under Kubernetes management or orchestration. So Kubernetes could be run on-premise on the cloud, could be on GCP cloud or AWS or any cloud vendor that's currently support Kubernetes. And the whole idea is to have those each one of the stage as components. So those components and even the whole pipeline can be assembly or distributed as standalone components, even throughout the Google Marketplace or Google Network, what they call AI Hub, right? I'm talking about, I'm focused mainly on Google as our main platform of the demo, but in everything that I'm talking here is applied to different cloud vendors, right? When I talk about Kubeflow in particular, the core machine learning development, machine learning code, it's a central piece, of course, but it's involved different many other pieces up to the point where I can create a machine learning ML code and model. Some are directly involved with the business process itself in terms of data collection, data verification, analysis, feature extraction, feature engineering, but some others are more related with the infrastructure. So things like a configuration, having the infrastructure of itself, monitoring, resource management, and so on. So the idea is to encapsulate the main business codes related to AI modeling. So the data engineers and data scientists can focus heavily on the modeling piece itself, and maybe and probably have a more supportive stages in terms of data preparation and deployment to production. And the other activities related to infrastructure itself should be abstracted for the effort, right? So that's when Kubeflow get in. So have a different stage, different pipeline with different stages, comprised of data analysis, data transformation, data segregation, actually building the model, validating the model, training, rolling out to production, monitoring, and logging. So it could encapsulate all that in a container. And then the two main benefits here is to be able to be more portable and scalable. So you can port your whole pipeline between different cloud environments, either in a local environment or training or cloud production, regardless of the vendor. All of the complex in terms of the physical infrastructure or even cloud infrastructure is abstracted through the Kubernetes layer. Not only that, each one piece it's portable, and also everything is scalable. So you can scale up or scale down the number of containers or number of nodes serving a container or pod based on the Kubernetes configuration. Mainly, the data scientists and data engineers are going to use, especially the data scientists, are going to use notebooks as probably very used to Jupyter notebooks. So Kubeflow also can provide different notebook servers. You can have different notebook servers for different teams, and each team, of course, can have as many notebooks as they want. All right, so we have the cluster created. Let's try to create the pipeline itself. I'm going to set all the default configurations and then deploy. So I'm going to move. All right. Going to take a while also. And then again, we're going to create the pipelines as a composition of different components, and each component can be reused in different pipelines. And each stage here as could have an idea are a container. So each step could be scaled up or scaled down according to the usage. And it's only a temporary infrastructure that once the pipeline is run, or let's say the last stage would be the deployment to production, all the previous steps from the pipeline are discarded. They don't keep the machines and infrastructure up and running indefinitely. Another tool that's come along with Kubeflow is Catlib. So once you need to try and experiment different hyperparameters, Catlib can receive the hyperparameters that you want to tune and the range of values and the business rule that want to try out different parameters, and then present its configuration. On the top left here, on the leftmost area here, you can see the main goal metric that was set by the data science here, and the main metric that was used was accuracy. And in order to reach the maximum of the available accuracy in the combination of the hyperparameters provided, it achieved 97% of accuracy using a learning rate of 0.011 and a batch size of 170. Also, it presents the idea of experiment. So each run that you do, you can have the historical runs of it and compare the results side by side. I also have the idea of a serverless infrastructure, which is KF serving, that's run over Kubernetes infrastructure, or even Knative with the Anthos component to be independently of cloud vendors. And within that serving, the tool set, the machine learning tool set that you want to use for TensorFlow, PyTorch, Scalable, or any other, it's available to you, right? So mainly in order to simplify the whole demo, the whole process, we're going to use Kubeflow on GCP as a managed service. So don't have actually to configure manually all the clusters, all the deployment of the Kubeflow itself. We're basically gonna use the managed service, have it all up and running. That's already what we're already doing right now, and then run our hello world, our little demo in terms of business process, right? So let's see our demo. It's up and running. So the idea here would be I want to try to correlate the stock market and an exchange rate of accuracy. I could do that, for instance, the euro and dollar exchange rate in comparison to the German stock market. But as being a so much stable market and stable currency, probably is not as much fun as using developing countries' currency like Brazilian real. So I'm going to try to do and correlate the Brazilian stock market against the exchange rate between Brazilian real and US dollar, right? So I have data sets that are generated based on something like that with using Google Finance, which is I guess I have of the years 2018 and 2019. I don't have the COVID period. So yeah, that's it. So that the exchange rate between Brazilian real and US dollar. So in the past, in 2018, it was around 3 something, or then it moved to 4 something, and now we are at 5 something. for exchange rate. And in terms of stock codes, stock market codes, I'm gonna evaluate the Bovespa, which is above the ticker. All right, and of course, the points of the Brazilian stock markets is on the scale of thousands. I scaled down to divided by 1,000. So here I have codes of 115, 116,000. I'm gonna use mainly this value divided by 1,000. Of course, I should have to correlate each specific date here, because depending on the day, this Brazilian stock market doesn't operate, depending on a holiday, and the exchange rate is probably having its actual value, so that I should match each date of each value that you have here to be more precise. To be honest, I already have this file here separately, at least for the years of 2015, 18, and 19. Let me see it. I guess I have it here. Let me check. All right, here it is. So I have the USD code for different dates, right? And Bovespa points in the scale of divided by 1,000, and have all these up to 2019, right? So that's the main data that we're going to use as training data for our ML model. Let's see how is the deployment. It takes a while. I guess we have it. All right, here you have it. Gonna open the pipelines and also see the notebook servers. Let's create a notebook server. So here, I'm gonna create a Python notebook. Oh, let me create the server anyhow. So let's use TensorFlow as a base. Could use a different frameworks, either Python or PyTorch or whatever, but let's use TensorFlow, for example, without GPUs to be a little cheaper for this demo. I guess it's fine in terms of, let's put US Central, right, it's fine. And assume that the notebook server is up and running, let's create our first notebook. So the first step here would be to import Kubeflow libraries. So I'm going to pip install Kubeflow platform pipelines. All right. Then our main pipeline will be very simple. We're going to be a linear regression. Get the path here. All right, that's our data. So, all right, let's import the Kubeflow libraries. All right, and there's different ways. There are different ways to create components and create the pipelines. The one that I use mostly is defining functions and then encapsulating functions within components in which they could create a container, right? So let's define a function. When I use a three-stage pipeline, one for training, one for the validation, and another one, the last one for prediction. So we're going to use sklearn, the linear regression, and the train step. We're going to basically have the feature that we're going to watch the feature column that we're going to use here, the label column that we're going to use, all the parameters of the function, and finally the file. In our function, I'm going to return the coefficients intercept of our linear regression. All the imports you have to do within the function, so within the containers, it also replicate that code. Let's create an instance of the linear regression. Then train, let's fit, use the fit model. Passing the features and the label that we want to predict. All right. Fit. and you're going to return the coefficients tuple. So have our function defined. Let's then create a component based on that function. So we're going to use the library components, create component from function. You're going to pass the name of the function, the name of the YAML file that generated to describe the component, and finally the base image that we're going to use. So the base image is this. Base image. The function, which is string, the component file output component. That's it, and let's save it in a variable called string component. Missing a common here. All right, that we have our first component. Then the second stage is going to be validate. Validate going to be very similar. You can have the first parameter here as the output parameter from the last stage, which are those, the defining of a regular linear regression, coefficients. I could even send the whole object. It's a little bit more complex in terms of configuration. In order to simplify the process here, we're going to use this definition here, linear regression coefficients, and then we have the feature, the label, and the file, very similar to the two here, feature, label, and file, and the output is going to be a metric, a score metric, R2. All right, you basically have to repeat the process as though are not pressing the whole object here. Right, training fit, and then here have to calculate the score. So we're going to define a variable R2, and then haggling score, passing again the features and the label. So I'm going to calculate the R2, and then I'm going to return R2. We have our second component, very similar to this. We have here the validate function to describe the validate component, the YAML file validate, same image base, and I guess that's it. And finally, our last step in our pipeline is the prediction itself. We need to have the score as a first input, and the feature and the value that we want to predict plus the file. So have the score, floats, then we have the feature, and we have the value that we want to predict, the values. And here the output gonna be a float with the prediction. All right, I'm gonna again repeat the process. I'm not passing the whole object itself. And then I can create future data frame here, which is pandas data frame. So create a data frame with the name of the feature. And a single row with the value. I could have different values, but just to simplify, I have a single value. And then I'm going to return the predict function passing the feature data frame and the first record that it returns. Finally, create our last component in order to create the pipeline. Here is predict. 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 All right, now we have it. And finally, I'm going to create the pipeline. This annotation here. Right. And the pipeline itself, it's also a function. With feature label. Don't have to be so strict on the types here. And then connect all the components as tasks. So a task are instance of the components. So create the train task. Passing the values, feature label file, and then we have the validate task. which is an instance of the validation component, passing as a first parameter the output from the previous test, the previous component. That's how we connect different components within the pipeline. And finally, the predict task, which is use the validation task output as the first parameter. Then you have the feature label value and file. That's it. Define the function. Now let's instantiate our pipeline, passing different arguments. So let's specify the arguments as a dictionary. So what we call feature, we're gonna have the value of above. The label is USD, and then the file, it's a long path. Let me have it here, like a constant. All right, that's this file. And finally, the value. But when I predict, let's try to predict once Bovespa reach 100,000 points or 120. All right, yes, that's it. And then I'm gonna create a client. With the configuration that you have here. Here you have it. All right. And you're basically gonna call create and run from pipeline. Client create run create run from pipeline function or pipe as parameters, and arguments have our args. Let's cross our fingers. There you have it. So remember again, each stage is going to be a Kubernetes container. So depending on the configuration, it may take a while to ramp up each one of the container, but using the TensorFlow one that you use, it's quite fast. So it's running the first stage. It's creating the container. Let's see the log. I defined wrongly a function. Here it is. Here it is. All right, let's rerun everything. All right, it's run already. So the first step here, the main output was the coefficient and intercept that you had it. And the validation phase received as train output the coefficients. It became input for this stage. And then the output here was a R2 matrix. It's supposed to be close to 1 as possible. It's quite good enough. It's not the only method should be looking at, but anyhow, it's an example is a good one. And finally, you have the metrics as an input and the 120,000 points for Bovespa pricing point in order to calculate the forecast for the US exchange rate, which is here 4.116. That's really nice, right? So very simple, hello, almost a hello world here, but the idea is to give you an overview and experience how it works. And once again, the main idea here is to be able to produce portable components and portable pipelines, also scalable with different infrastructure controlled or orchestrated by Kubeflow or Kubernetes underneath, right? So thank you very much. If you have any questions, any doubts, please let me know. You have here my contact information. Thank you very much. Bye-bye.